So welcome back. Last video you either checked it out to get the basic fundamentals of RAG down, or you already had that knowledge, and this time we're going to start looking into the code. We're going to look through this notebook, which is basically going to create a simple RAG system from start to finish. So without further ado, let's have a little look at this notebook. Let's zoom in, have a look at the code. We'll see straight away we're going to be installing a library called Llama Index. And in these notebooks, we're going to either be using Llama Index or LangChain. These are the Python libraries that are going to allow us to hook up with these large language models. They're going to have a lot of functionality. You don't have to use these libraries, but you'll find that they're going to have at least some functionality, which is going to be useful to most workflows. This time we're working with Llama Index. You'll be able to check out this code in detail by seeing the link in the comments, which will take you to the GitHub repo where you will find all of these notebooks. So let's zoom in a little bit more, make sure we can see this code. And so now we're working with Llama Index. We're actually going to go out to Hugging Face, and Hugging Face is where we're going to get our large language models and our embedding models that are open source, so we don't have to be paying OpenAI or some other service to do all of this computation. So we're going to be using Hugging Face, and there are so many models on Hugging Face that people have developed. Like I say, they're open source, and you can see all the lists of the latest and greatest and best performing models out there. So we go to Hugging Face, and you're going to need a token. And this token is going to give you access to Hugging Face. You can download things from Hugging Face without a token, but at some point you'll get limited. So get yourself a Hugging Face token, and then we're going to quite simply be able to connect to the API here, and we're going to be using an instance of this Zephyr 7 billion parameter model. Now, compared to things like GPT 3.5, this is a very small model, but these large language models are getting more efficient all the time, and you'll find that this 7 billion parameter model is actually very effective. So we're going to be running that in the cloud. We don't necessarily want to download right now this 7 billion parameter model. I mean, it's small compared to GPT 3.5, but you do start to struggle for space if you want to use those locally. We got a large language model. We're going to need an embedding model. This time we are going to save that locally, and once we save that locally, you'll see it doesn't take a long time, and this is BGE small. This is an embedding model which is very small. It's very efficient, and it's downloaded a lot, and it's going to be sufficient for our purposes, and you'll see that it's going to give us fairly decent results. Now, once we've done that, what we can do is we can use these settings to hang our large language model and our embedding model off. And so that means we're not going to have to specify every single time we call one of these Llama Index functions which model we're using, which models we're using. And so what will be useful now is if we just have a look at this little diagram that I've just drawn a few moments ago. It's very simple, this process. We're going to have some data, maybe it's some PDF. We're going to read in that PDF. Once we've read it in, we're going to split up this PDF. And once we've done that, we're going to load it into some database which is connected to our embedding model, and that's going to make all the numeric representations of all of this text. So if we go back to the notebook and let's start going through this process. And so here we go. This is the Llama Index directory reader. I've got some PDF file. Okay, And all I'm going to do is I'm going to read in that file and I'm going to load that data. Now, once I've loaded that data, what I finish with is some sort of list, and this is being split up fairly arbitrarily into 76 pieces. But I want to be able to specify exactly how that document is split up. And so to do this, I'm going to use a node parser. And so a node, that's the Llama index terminology for a chunk of text. I prefer chunk of text. It's a little bit less ambiguous, but there's all sorts of vocabulary floating around it in the RAG world. And it seems like each library has got its preferences for which vocabulary they use. So it can get confusing. But when they're talking about a node here, they're just talking about one row or one chunk of text. So the key things, and there are lots of different types of node parsers, and we'll see a few of them here, just in this notebook. But the key things we're going to want to specify are the chunk size. So that's how many tokens we're gonna have in each of these chunks, and the other one is the chunk overlap. So just to make sure we're capturing the entirety of the meaning of this chunk, we're just going to take some text from before and from after, just so that we've captured the total content of this information. And what you will find is that this is a crucial phase in this workflow, because your system, your entire system, is going to work. It's going to be better or worse depending on how you've cut up your text. So you might want to do some fancy fine tuning or on your models, fine tune it to your data. But you will actually find that the simple things are going to be the most important. Exactly how you cut up your document is going to be crucial as to how well your final system performs. So once we've cut up this document, this PDF, now we've got 83 different chunks. We can examine one of those chunks, and you see this is what we get. We get this text node object. It's got its identifier, and it's got this here, all of your metadata. And you can see it's got information. This is from page number 48 in the PDF. And this metadata is going to become important. We'll look at that in the next notebook, because we will be able to filter these text nodes based on the metadata. But also, crucially, we've got this text attribute. And if we have a look at the text attribute, that is the text that is going to be encoded by our embedding model. And so, yeah, we have this text and we have this metadata. So another way of splitting up these documents, for example, you can specify in regex exactly when you want these documents splitting up, some sort of regex pattern. Okay, when you see this pattern in the document, create another chunk. So that's one possibility. And the one we're going to look at, and the one we're going to use today, is going to be the sentence window node parser. Now, essentially, what we're going to do here is we're going to split our document up into much, much smaller chunks. And the reason that we might want to do that is because if you imagine a large portion of text and you have some sort of numeric representation of this large text, imagine there must be some sort of loss of information, because there might be a lot of different concepts in that large portion of text. If we got a smaller portion of text, then our numeric representation is going to be much more precise, and we're going to lose less information. So the idea of this sentence window node parser is that we work with small chunks of text, but this is problematic when we go to our large language model and we give our large language model a really short sentence, because it's not going to contain an awful lot of information. So this idea is, okay, well, we're going to search small pieces of text, but when we go to the large language model, we're going to give that all the information before and after that sentence, so that there's something some meaningful context for the large language model to work with. So that's the idea of what we're going to use. We're going to use this sentence window node parser. And so we're going to get a list of new nodes. Now, this new nodes, you'll see that we don't have 80, however many we had before. We've now got 953. We'll see that these are much simpler sentences now. We have this metadata key, which is now called window. And this window is going to give us all of the surrounding text. But the actual text that we got the embedding from is going to be very small. So there we go. That's the window. You'll see that this actual text here, get a closer look, is contained within the window. But we're not going to give just this get a closer look. We're going to give all of this surrounding context so that the large language model has got something to work with. So now we've done that, we're going to need to create a database. We've split all our documents up. Now we need to create the database. This is the simplest type of database we can use in Llama Index, called the vector store index. You can hook up to Postgre or any other vector database that you're going to need. There's going to be functionality for that in Llama Index and in LangChain. And all we do is we're going to pass our nodes to the vector store index. Now, I've already done this. I've already run this notebook. I'm running it on the CPU, and because we didn't have a huge amount of documents, that was fairly quick. But I am in the Google Colab, and you see in Google Colab, you'll have the option. And when you're using these large language models, a lot of the time you will need it. You will need to access a GPU. So Colab is going to be a very useful tool for you, because you're going to be able to get access. You can even get free access to a GPU, or get yourself a Colab Pro for £10, $10 US a month, and you're going to be able to have enough processing power to run these notebooks. So we have got this vector store. This is our database. It contains all the information of our document. It has all of the numeric representations. Now, we are going to have to use this post processor, which is going to allow us to pass not just the sentence used to make the embedding, but it's going to allow us to pass this window to our large language model. And in Llama Index, what we're going to do now is we're going to create a query engine. And this query engine is essentially what's going to turn our index or our vector store into a RAG system. And we have to pass it this object that we've just created. And so now we're able to query this query engine with some sort of question that is going to get some sort of numeric representation that's going to be compared against the vector store. We're going to get some of the most useful text from that vector store, and that's going to be passed to the large language model. And all this is going on under the hood, and the large language model is going to give us, and has given us, some sort of response. And so we get, where can I share my notebooks? Okay, the new Microsoft Office Backstage, your notebooks can be shared easily, blah, blah, blah. And so in this response, we're also going to have access to all the chunks of text that was used by the large language model to generate. And we can see, if we look at the very first chunk that was used, we can see the original chunk for the text embedding. Sometimes you want to share your notebook with friends and co-workers. So this is, I want to share my workbooks. So we found the embedding models worked very well. We found the pertinent text, but to the large language model, we passed all of this information. And with all of this information, the large language model was able to generate some useful answers. So that, in essence, is a very simple RAG system. And this time with Llama Index. And so next time, in the next video, we'll start to look at how we can start manipulating some of this metadata.